Alrighty, so as promised, wanted to go through and do a quick walkthrough on the practice quiz version 1C that we've got posted on the quizzes page, or quiz 1 page on the Canvas site. So for this one, we're going to be creating this object. I've got SOLIDWORKS open, and importantly, our units down here are in millimeters. So we're only going to be using extrude and extrude cut as we work through this problem, and all of our sketch tools are potentially allowed. So, getting started with this, we'll create ourselves a new part file, and this one's going to be in millimeter units. So once our file opens, we're going to set our units mmgs. If you're working on the VDI, I think it'll give you a pop-up. But anyway, we should probably take a quick look and consider what we might want to start with. So this one actually acts as a pretty good example for why it is that we put time into considering what our front view should look like. What we've got here is our right view should probably be the front view, and the isometric could be rotated a bit. But anyway, we do see that we've got most of our detailing over on this right view. So we're probably going to want to begin with a sketch on our right plane. So opening that up, you can then see that we've got sort of a base extrude, and that one's going to go out 30 units. And then we've got this little peg that's kind of hiding in our isometric, but we can see it a little closer in the right view. Sort of a square peg that is then going to be inset in this slot shape, so we're going to need to cut out that slot second, and then we can create the peg and extrude that out. So, getting started with this, choosing an origin is usually a good move. And another thing that we can note is that we've got this sort of long tail over here. This seems like the centerpiece of our sketch, so I'm just going to start on this. And then we can go and add this sort of blocky bit afterwards. So for that, the dimensions that we've got are dimensioning to the outside of this loop. And importantly, we've got this consistent 10-unit offset. So probably what we can do is we can do an outer loop, and then we can use an offset entities to get the inner loop. And that then ought to get us all set up there. So let's begin with the arc. I think I'll put the origin on that center mark there. So I'll use the center point arc tool. Looks like it goes from about there to about there. Doesn't need to be perfect, but the closer we get it, the easier the rest of our job gets. Then we've got this smaller arc up here, and this one goes, looks like it connects in smoothly, so we see we've got these tangent edges indicating that these all sort of smoothly flow together. So I'm going to use the tangent arc to get that, and then it goes up to vertical, and then we've got a little vertical line up here. Similarly, we've got another straight line coming off at this 40-degree angle. On the inside of it, we see that has that same tangent edge, so we can probably assume that this is going to be a nice smooth connection. Another way that we can make that assumption is if we look in our top view, we would expect to see a hidden line around here if there was something going on that would have caused for a sharp corner, but I don't see any hidden lines up there, so we're probably good. I do actually see a hidden line here, but that actually comes from this sort of vertical tangency plane, or this sort of apex of the arc over on the left side. So we've got that, then we can do our other diagonal line over here, and it looks something like that-ish. So I'm going to break from my usual script of drawing the entire shape and then dimensioning it. I want to try to do dimensions for this first, then we can do our offset, then we'll get the rest of our geometry in place. It is doable if you do it in the other order. It's perfectly fine. It's just, in my opinion, if we've got something that's going to be a major offset, we want to do that first, and doing the offset gets a lot easier if our thing is already dimensioned. So for this edge, we see that's a vertical 25, sort of going from the end of that line to the center mark, which is then sort of horizontal with the end of the arc and the end of that line, which is also done by just having a tangency relation going to a vertical edge there. And then we've got a 45 going from that top point to the center mark of the larger arc down at the bottom. That one's 45. And then we see we've got a 2x R18 telling us the size for this arc. And then we've got an R18 in parentheses up here. So a dimension in parentheses means that it is a reference dimension. So we can't use that numeric value directly, but it does allow us to assume some geometric relation. So the R18 here, the 2x R18 here, it would make sense then that the 2x is applying to both of these arcs, which would mean that we'll dimension one of them and then set the other to be equal. So I'll dimension this one here since that's where we've got the dimension. And then we can apply an equals relation. So make sure you hit escape to deselect everything first. Hold down shift, and then you can select your two arcs. Equals. Cool. Then we've got our 40-degree angle here, but that one's going to be easier to deal with once we've got this vertical edge. So at this point, I think it would now be good to do our offset. So I'm going to go to offset entities, and we see that this offset is 10 units, so we've got our 10 there. And then we can select our edge. Any one of these will do. And it looks like that should do it for us. So we'll hit our check mark. That adds our 10 dimension. If you're doing this in paper, you should be crossing out your dimensions as you get them. Doing this sort of recording doesn't work as well if I've got a sheet that I'm scribbling on my desk, so we're just going to do our best to remember which dimensions we've already used. But then we can finish off our sketching. So we see this bit up here is capped off. So we've got our horizontal line there. Then we've got this sort of shape over on our right side. So at the top of this endpoint, it sort of goes out horizontal, then it goes down vertical, then we've got our tangent arc, and it looks like this goes down a full sort of quarter circle, so we do see from our center mark that we get that vertical line, telling us that this does go all the way down to the bottom, and it looks like we've got a little horizontal blip on that sketch as well. So using our line tool some more, we'll go horizontal until we're directly below this point here, and then vertical to cap that off. Cool. So plenty of other ways you can approach this, of course. Just brute force doing all of these line segments is also perfectly valid. But figured, well, I'm showing a technique to do this, I might as well show a slightly easier technique once you know what the tricks are. Also, we can see that we've got this little dashed line here, and that is sort of indicating that if we were to create a construction line between these two endpoints, that construction line would be perpendicular with the object lines that we've got. So, easiest way to sort of enforce that is to just add it ourselves. So I'm going to use our center line option here to draw in our little construction line. Then we can take that line and one of these edges and apply a perpendicular relation there. Cool. As far as other relations that we can assume, we see that this 45 dimension not only goes to this top bit, but then we've also got another sort of guideline indicating that that same dimension is affecting this top edge over here. So that means that we can pretty much say that that top edge and this top edge are going to end up being collinear. So that then gets those two to play nicely. Alright, at this point, I think we've done all of the obvious geometric relations, so we're then going to go on and do our dimensions. So we've got that 40-degree angle that we haven't used yet, so that is measuring between these two lines, 40 degrees. There we go. Cool, so that gets our angle in place. Then we can do, let's do this 90 next. That's going from our center mark to the vertical edge over here. Center, vertical edge, 90 units. Then this arc is a radius 25. Nice and easy, 25. There we go. And let's see what other stuff can we use here. These two center marks that we see are along the same sort of horizontal edge. So what we can do is then just hold down our shift key, select one center mark and the other, and apply a horizontal relation. There we go. That gets us fully defined. So far our sketch looks like our object, which is a pretty good sign. Then we can go over to Features, Extrude Boss Base, and this one we see is extruded to a depth of 30. Standard best practice is with your first sketch, or your first extrude, if the first feature of your model is an extrude, Usually it's a bit better to do it as a mid-plane extrude, just to give us a little bit more, or a couple more planes to work with. It doesn't actually matter for this problem, but just so that I'm not being a hypocrite, I'll go through and set that up there. And then Control 7 to double check our orientation, and we see that we are on the right track so far. So that, as one would hope, was the majority of the work on this problem. Then we've just got these two more extrudes. So we've got an extrude cut for this slot shape. So for that, I'm going to create a new sketch on this right surface. And we can draw in a straight slot feature. So this, or a straight slot curve, I guess would be the right term for it. Excuse me. So this effectively acts as a rectangle with the tops and bottoms rounded off for us automatically. So then we don't need to go through and sketch it on our own. But for that, vertical line, sized something like that ought to do. And then we've got to dimension the thing. So vertical line, set to vertical, we're good there. See that this has a 2x R6, so that means that both the top and bottom arc on this are going to end up being 6 units. So dimensioning that, 6 units, there we go. Then, let's see, what else do we know about it? We know it's 34 units from top to bottom. So dimensioning that, 34. And then the last thing that we need is something to actually locate this part, or locate this sketch. For that, we can see that we've got a center mark for our top arc, but the center mark for the bottom arc is the same place that we had the center mark for this radius 25 down here. So what we can do is we can grab that edge, hold down shift, and grab the object edge there, and then if we apply a concentric relation, that sets it so that these two arcs share that same center point. So that gets our sketch fully defined for us. Another way that we could do that is if we wanted to reveal the sketch from our first boss extrude. So we can right-click Show. And of course, the gray just perfectly matches up with the color of the object at that perspective. If we set it to, I think, copper, yeah, then we can get it to pop out nice and easy. We'll just delete the material afterwards. But for this one, we want that center point and this center point. Oops, helps if I'm editing the sketch. We want that center point and that center point to be coincident. So that'd be another way you could go about defining it. Cool. So now that we've got our sketch fully defined, we want this cut, and we see that it cuts until it is 10 units away from this back face here. So for that, we want this to end at an offset that's 10 units from this surface. So if we check direction 1, we do see that there is an offset from surface end condition. So we'll select this face there as our input, and then we can plug in our 10 unit offset. And then we want to keep an eye on the preview and make sure that where it's showing here, it's offset 10 units in, instead of offset 10 units after. So that is in the correct orientation. Looks good. Control 7 to double check. Yep, we're going along good so far. Just going to go hide that sketch real quick so we don't have to keep looking at it. And our last bit then is this little square peg that we've got in there. So for that, we see that it sort of starts on this surface at the end of the cut, and then it goes until it's 6 units offset from this surface. So we could do it pretty much on any one of these surfaces that's parallel to our right plane. I'm just going to do it so that the sketch is actually on that surface there for convenience, but you could decide to do things in a different manner if you would like. For this one, we can use the rectangle tool, and it looks like it's going to be somewhere around here-ish. We know that this one's a square because we've got that little square symbol next to our dimension, and a little note indicating that square is square, which is always important. And that would then mean that the two sides of our rectangle here are going to be equal, or the two perpendicular edges, I suppose would be the more accurate way to say it. And then we see that this one is 7 units. So dimensioning that to 7. There we go. Click drag to move this over a little bit so that the other dimensions are easier. Make sure you hit escape a few times before you do that, just so that you don't accidentally start adding dimensions to stuff. Then it's dimensioned so that it's 2 units between the right edge of it and the right wall of the cut. So smart dimension from that edge to this edge. 2 units. And then we got another one is 23 units from the bottom of our square to our center mark. So going from there, and then you can dimension to a center mark by dimensioning to the arc that it belongs to. And that is 23 units. Cool. Gets our sketch fully defined. So we can go over to features, extrude boss base. And this one goes offset, or up until it is 6 units offset from that right face of our object. So we're going to do the same offset from surface, selecting this face as our offset surface, and then we can type in our 6 as the offset distance. Control 7 looks good. Then we can just right click, remove material, just so that we're back to the SolidWorksium setup that we had before. And yeah, looks good. So at that point, save it. We want to save to wherever it is that we've got our stuff saved to, and using our naming convention, Williams, Tyler, yes, cool. At that point, you then go through and upload the file through the Canvas quiz. So hopefully that was useful, and if you've got any questions, feel free to reach out or come by office hours. Good luck on the quiz, and I will see y'all soon.